going full circle to really build out a nice calculator using Python. You want to be able to plot mathematical functions. Let's take a look at how to do that. So it's kind of interesting because you want to do something like this, y equals x squared. Okay, let's say that's what we want to plot. Okay, that's good, that works. But how do we specify x, right? When we're doing it in math, we're just like, oh, it's the real line, but there are an infinite number of numbers on the real line. In programming, that's not going to work. So you actually specify what your x is in programming. You do that using something called linear space. So I'm going to import NumPy here. And if I do np.linspace, okay, I can go, say, between -10 and +10. And the last number specifies how many points are in between. Now, if I just made it like 20 points, or I guess maybe 21, it's going to sort of include just the integers. But if I want to do a bunch of points to simulate a real line, you know, I might want to do something like 2,000. Okay, and so that's what I'm going to set my x as. Okay, so my x is going to be a NumPy array of all these points. And now, when I specify that y is x squared, it's going to be the square of each of those. And just to show you that before we plot it, let's just view x and y in comparison. Okay. Okay, so you know, it's a lot of points, so hopefully I won't try to show all of them. I mean, it's going to be 2,000. And the idea of linspace is that they're spread apart evenly, and you can see you end up with sort of the squares of these numbers of each one of them, you know, on the bottom, and you can see the numbers that you get on the top. Okay, but instead of printing them, we want to graph them. And how do we do that? Well, there's some different ways that you can plot numbers. I'm going to use, we're going to import matplotlib.pyplot, because a Python plotting library, as PLT. Okay. And what we can do now is plt.plot. Okay. It's just a straight plot of x, comma, y. Right? And well, I think that's correct. What we're going to do now, I'm wondering, is it okay just to have y there? Let's go ahead and run the code and see what we get. And you can see you actually do get a nice looking parabola. Okay, very cool, very interesting, right? Okay, and one thing I forgot, you know, it shows the extra line at the top. If you do plt.show, it'll actually get rid of the line at the top. Okay, so that's the baseline of how you would do a plot. Let me make a couple of modifications here. Well, one thing I like to do is I like to import Seaborn as SNS. Okay, so let's do that. Import Seaborn as SNS. So Seaborn is another plotting library. But they have this SNS.set. It's a really nice sort of gray background with the white grid lines on it. Okay. Now, additionally, you can sort of choose how you want the parabola to be represented. You know, what you can see Matplotlib is doing is showing it's centered, and it goes up to 100, but it's not really scaled. So if you want to scale it properly, you can sort of like set your limit. You know, you can do like plt.y limits, okay, and you can go from like, you know, if you want it to be symmetric, you're going 20 on the x, maybe do it 0 to 20 on the y. Although I will tell you sometimes the 0 cuts off, so it's good to go like -1. Okay, so let's look at just what happens with those two changes. Okay, so press Shift-Enter. And now you can see we get something more drawn to scale as to what the parabola actually looks like. Okay, that's closer to the shape. Now we don't have the classic x, y coordinates. I'm not going to bother with that because it's not common based on other kinds of graphs that we do. But to do something a little bit interesting, let's make a comparison. Okay, let's not just plot here x and y. Let's add some more. Let's plot x with e to the x, right? So y equals e to the x. Okay, that's cool. let's compare. Remember, e is about 2.7. Oh, look at that. It's underlined because I imported NumPy. It doesn't know e, but it knows np.e. That's the number e. Okay. So, and you know, this y is x squared comes up here. I think just, you know, maybe to make it clear and more consistent, I'll put that down here. Okay. Okay. All right, so now we've got two plots coming up. Let's see what happens. And you can see there's the difference. So e to the x grows more quickly. It goes straight up. And, you know, we could really expand this out too, right? We could go higher to see a bigger difference. You know, we don't have to limit y. Let's see what happens in this case. Okay, this is going to be interesting. Okay, so when I comment that out, I'm keeping that because I might want to bring it back. But what if I just let Matplotlib decide? Well, look at this. This is amazing. Okay, e to the 10th is this gargantuan number, and it makes the parabola by comparison flat. This shows you the power of exponential growth. I think this is awesome. Now, to sort of pick, you know, you can pick, right? You can say, well, I think that's too much. Maybe you just want to do it between 0 and like 100. It's your choice. It's the same reality. I mean, that doesn't show you the reality of x squared. It looks like a flat line, which it's not. But it shows you the power of the exponential growth. And yeah, there you can see like it's, you know, it's starting to deviate more quickly. So something that's missing from here is a legend. Okay, and a legend is basically like which one is which, right? Can we do that? Well, you certainly can. And so it's plt.legend. But when you just put the legend in there, it doesn't know what to call it. It doesn't know which one is which, I don't think. So if we try it, it says like, hey, no labels found to put in the legend. We need to label these. And so let's label them. I think is label the keyword. Not 100% on that. Label, and then this is what it would look like. So you might want to say something like y equals x squared, right? That's that one. That can be a label. And then here the label would be y in quotes, got to be in quotes, y equals e to the x, okay? And so let's try this again. Okay, so now I've added labels. It's for the legend, right? And so now if I press Shift Enter, you can see it's positioning it to in a place where you can see it. It's showing now which one is which. And this is kind of nice. And for the fun of it, let's just do one more. Let's add on just y equals x, right? The straight line. And so this would have a label equals y equals x. So now we've got 3. And the other thing is like you can change the location. So, oh, it's crowded over there. Can I get the bottom right? I think you can. You can do location. I believe it's just, was it loc equals, and then I think you can, I think it's something like bottom right. I might not have that quite right. Okay, but you can move it. And press Shift Enter. Okay, bottom right is not valid, but look, they actually tell us, which is nice. It's really nice when they do that. And so, you know, I guessed incorrectly, but it does say I can do lower right. Okay, so I want to do lower right. Thank you, Collab. Very nice. And now it's going over the other graph. You know, so, you know, you could just let it choose. But now you do see the 3 different lines. Now we're missing the bottom half of this other line, so maybe we want to change our y value here. Let's just tidy this up a little bit. Go all the way from -10, perhaps to 100. If we do that, the location should be solid. And I think that should probably do it. I would still didn't quite, you know, let's see where it puts it if we don't tell it. Okay. Sometimes it'll just find an optimal place. And you can see now it's showing in the middle because it's not blocking anything. So that's how you can do some plotting. Pretty cool. And, you know, you're able to, in effect, turn Python not just into a powerful calculator, but a powerful graphing calculator as well. And I will also conclude in stating that this plotting is actually not restricted to sort of mathematical graphs. These libraries are going to be used for a lot of data analytics to show a lot of beautiful plots. They're valuable libraries to make sense of large data that just from numbers the human eye cannot make sense of.